Welcome back to Arxflix. Today, we're diving into the paper titled Exploration into Translation Equivariant Image Quantization. This study highlights how traditional image quantization fails to maintain translation equivariance due to aliasing. The authors propose a novel method to tackle this issue by enforcing orthogonality among the codebook embeddings. Here's a visual example demonstrating how orthogonal codebook embeddings maintain translation equivariance, unlike traditional methods. Let's dive into the key concepts and findings of this research. Image quantization, or vector quantization, is an encoding method that represents images in a discrete latent space using an encoder and decoder. This approach is particularly efficient for multimodal tasks like text-to-image generation. VQGAN, an extension of VQGAN, is a significant model that uses adversarial and perceptual losses to achieve sharper image reconstructions. A key challenge with existing quantization methods is their inability to maintain translation equivariance. An image quantizer should represent semantically identical objects with the same indices, irrespective of their location within the image. This falls apart in current methods, as illustrated in Figure 1. The failure to maintain translation equivariance is due to aliasing, caused by downsampling operations such as strided convolution or max-spooling. Traditional anti-aliasing methods apply low-pass filters during downsampling. However, in a quantized space, the noise, denoted as epsilon, doesn't need to be zero as long as the features map to the same codebook index. The authors propose a novel approach where they achieve translation equivariant image quantization by enforcing orthogonality among the codebook embeddings. By regularizing these embeddings to be orthogonal, small deviations due to aliasing can be ignored, leading to consistent codebook index assignments. The method ensures that a translation operation in the image space, denoted as T, results in a corresponding translation operation in the quantized space, T. By enforcing orthogonality in the codebook embeddings, the authors ensure that quantized features remain consistent despite slight shifts in position. VQGAN, the proposed model, uses a regularization term in the loss function to enforce orthogonality among codebook embeddings. This approach helps the model to map similar features to the same codebook index, despite minor variations due to aliasing. Examples from the controlled dataset used in the experiments show carefully positioned digits within a 64 by 64 space. The authors conducted 3 key experiments: text-to-image generation, image-to-text generation, and analysis of sample efficiency. Our approach demonstrated a significant performance improvement in text-to-image generation over baseline methods. This clearly shows the importance of maintaining translation equivariance in the quantized space. For image-to-text generation, the improvement was also noticeable, but smaller compared to text-to-image generation. This is likely due to the high sensitivity of text tokens to minor errors in image representation. Finally, VQGAN outperformed vanilla VQGAN when trained on a smaller dataset, showcasing its sample efficiency. This suggests that translation equivariant quantization can be a potential solution for scalability issues in modern generative models. The VQGAN used fewer codebook embeddings to represent images, akin to using essential colors to depict a rainbow. Although this approach results in minor sacrifices in image fidelity, it facilitates a better understanding of the semantics, which is crucial for multimodal generation tasks. In summary, this study explores the novel concept of translation equivariant image quantization and demonstrates its effectiveness through various experiments. Future research could expand this approach to real-world datasets and more diverse downstream tasks. Thanks for tuning in to Arxflix. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cutting-edge research. See you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.